Hi students, here is another video about transformations because you just haven't transformed enough, have you? Okay, so the good news about learning about transformations is that nothing has really changed. Our A, K, D, and C values continue to do the exact same thing. So today we're just going to be transforming cubic functions, so the parent function is x cubed, and quartic functions, so the parent function is x to the power 4. So I'm just going to show you visually that they do the same thing. So here I've set up my cubic with my A value out front, K value factored out so you can see the D value, and then adding C. So my A value, the default is 1 because in the parent function it's just 1x cubed, right? So the A value, if you increase it, vertically stretches x cubed and makes it taller and skinnier. It's like you're pulling it up like this. And putting it between 0 and 1 would vertically compress it, so push it like that. Making it negative would flip it on the x-axis like that. Whoa. But then if you make it less than -1 there, then it's also being stretched. Okay, so that's the A value. Our K value does the same thing as normal. So if you stretch it, if you can make a K value that is greater than 1, that is a horizontal compression. So that's like you're squishing it in horizontally like this. Okay, and between 0 and 1, that's a horizontal stretch, so like you're pulling it out. And a negative K value will reflect it on the y-axis. So with cubic functions, it doesn't matter if you reflect on y or reflect on x, that does the same thing. But for quartic functions, that does matter, that does affect. That is a different type of reflection. So our D value, like normal, moves left and right. So the default D value is 0 when it's at the middle there. And the C value will move it up and down. Whoa! So there you go, same as always. So let's just get to the note and see what kind of questions you can be asked here. Okay, so we're just talking about these parameters, which we've already kind of done. Now we're going to do some questions around it. So if I ask you to graph something like this, it's just like what we're used to doing. You have to factor out K first. So the parent function here is y equals x cubed, because you can see the 3 there. But let's factor out K to make sure that we are doing that properly. So minus 8 1/2 bracket x plus 2 cubed minus 3. So we can see that our A value is -8, our K value is 1/2, our D value is -2, and our C value is -3. So the transformations being performed are a vertical stretch by a factor of 8, a reflection on the x-axis because we're reflecting down, a horizontal stretch by 2, okay, then a translation left 2, and a translation down 3. Okay, so if we're to graph it, again, the best way is to start with your table of values of the parent function. So we'll go -2, -1, 0, 1, 2. So that's -8, -1, 0, 1, 8, and transform those points. So our x values are all being divided by 1/2, which is the same thing as multiplied by 2, and then we subtract 2. Okay, our y values are all being multiplied by -8, and then we subtract 3. So that's how we get our new function xy. Okay, so if you follow these operations, you get -6, -4, -2, 0, 2, and 61, 5, negative 3, negative 11, negative 67. Okay, so when we go to graph it, we just need to plot these points. So we increase by 1 on the x-axis, so I'll just label 2, 4, minus 2, minus 4, and we'll increase by tens. So I'll go 20, 40, minus 20, minus 40. Okay, so we plot the point minus 6, 61, so right up here. Minus 4, comma 5 would be right there. Negative 2, negative 3, so right there. 0, negative 11. And 2, minus 67. So notice this is where it curves, okay? Also, the end behavior makes sense because the leading coefficient is negative, so it makes sense that the end behavior would start here. Okay, reach here, and then start to curve down, okay? So that point where it changes kind of direction there, that's called the point of inflection. So it's whatever 0, 0 is transformed to is the new point of inflection. So that would be 2, minus 3 in this case. And so that is our graph f at x. All right. Now, another way of doing this, which is not as obvious, is that you actually could have simplified the equation first. So I'll show you how to do that. Now, this is not something that you have to do, but if you notice that you can do it, it will make your life a lot simpler, just in terms of the actual transformations. So notice that this 3 is this cube. This half is being cubed, and this x plus 2 is being cubed. So you can actually break it out that way, as 1/2 is being cubed, and x plus 2 is being cubed, okay? Well, a half cubed is just an 1/8, because 1 to the power 3 is 1, and 2 to the power 3 is 8. So minus 8 times 1/8 is actually just negative 1. So we can rewrite this a lot more simply. Negative bracket x plus 2 cubed minus 3. So here the only transformations are a vertical reflection, left 2, down 3. And that will actually turn out as the exact same graph that we have up above. So that's kind of interesting. So that means a vertical stretch of 8 and a horizontal stretch of 2 actually cancel each other out and get you back to no stretch or compression at all. So that's just something interesting that you can notice. Okay, so next page, let's see what other types of questions we have here. Okay, you will have questions where you're asked to determine the roots. Now just remember the roots, the roots, that's just another fancy word for x-intercepts. So when it's in this form, we can actually solve for the x-intercepts without having to do any factoring. So next time we'll learn how to do some factoring, or in a couple of videos, but right now we can actually solve for the roots by just rearranging. Okay, so remember that x-intercepts are when f at x or y equals 0. So you just set the function equal to 0 and just start moving each stuff over to isolate for x. So we get x plus 6 to the power 4 equals 16, because we move over the 48, divide by 3, you get 16. Now, when you undo a quarter root, you have to show, here I'm going to put the 16 and then use a different color. When you're doing the quarter root, remember you put the 4 here, but you also have to show plus or minus. But you only do the plus or minus if the root that you're taking is even. And that's because, well, think about why that is. Okay, because to take something to the power of an even number, either positive or negative will result in a positive. So that's why you have to consider both negative and positive roots, because either one of those would multiply back to a positive when doing it an even number of times. If this was an odd number, you don't do the plus and minus here. So if this is a 3, you don't do the plus and minus, okay? So then you get two different sets here. So x plus 6 equals 4. So then you get, oh, sorry, not 4, quarter root. X plus 6 equals 2. So x equals -4. Or x plus 6 equals -2. So x equals -8. So those are the roots of this function, the x-intercepts, okay? Then you'll get questions like this, where it's asking you to determine the equation of a quartic function, and it gives you what's happened to it. So stretched vertically by a factor of 2, that means that your a value is 2. Okay? Reflected on the y-axis, that means your k value is -1. Translated right 3, so my d value is 3, and up 4, so my c value is 4. So then my function would be 2 bracket negative bracket x minus 3 bracket bracket to the power 4 plus 4. Okay, I have to show my k value factored out, or else it's not done properly. So now I can just start by making my initial table of values for my parent function of the quartic. So -2, 16, 1, -1, 1, 0, 0, 1, 1, 2, 16. Okay, and then transform each of those points. So from here to here, okay, the x values are all being divided by -1 or multiplied by -1. It does the same thing. And then you add 3 to them. And then all the y values are being multiplied by 2, and you add 4. Okay, so I'll leave you guys to do that. That's pretty straightforward, and I think you're used to doing that. Okay, compare answers tomorrow in class. All right, so here is a practice question for you to do. Okay, so the first thing you should do is identify your A, K, D, and C values. So do that now. So your A value is -1. Your K value is 3/4. Your D value, careful, is -10. And your C value is -5. Your parent function is y equals x to the power 3, okay, because of this 3 here. And now you just need to create your initial table of values for your cubic function, which I did in example 1, and transform each point using what you know about how to transform points. So x over k plus d and ay plus c. Okay, so again, go ahead and do this example as well, and I'll have you guys check each other's work tomorrow in class and make sure that that's right. So make sure that you follow up on that and don't just leave that blank in your notes, okay? Then you may have a question like this, where it gives you the picture of a transformed function and expects you to describe the transformations that were applied. So notice that this is a cubic function. So the first thing to look for is its point of inflection, or the point where it's changed kind of its shape. So notice that it's at -4, -1. So the point of inflection is at -4, -1. So this is kind of the equivalent to a vertex of like a quadratic function. So if you know that it used to be at 0, 0, so if you look for the vertex, you can see how much it's been moved left and right. So the original point of inflection was here. So that means that this guy had to be moved to the left. So it must have had a translation left 4 and a translation down 1. So think about it. That means your D value would be -4 and your C value would be -1. Okay, now what has happened with a vertical stretch or compression? So what you want to do then is compare your point of inflection and see what happens when you move one unit over this way. Because normally when you go over 1, you go up 1 to the point 1, 1 in a cubic function, right? In y equals x cubed, when you go over 1, you go up 1. Here, when you go over 1, you're going up 3. So because this has gone from 1 to 3, that means there has been a vertical stretch by a factor of 3. Okay, so by a factor of 3. So your A value would actually be 3. Now you actually only have to identify a vertical stretch. You don't have to count this as a horizontal stretch. So if I did ask you for the equation, you would be able to come up with that. F at x equals 3 bracket x plus 4 cubed minus 1. And you can actually put that into GeoGebra and check that you get these coordinates, also the 5, negative 4. All right, so that's how you do it. You look for this point of inflection first, or if it was a quartic function, you look for its vertex first, and that will tell you the translations left and right. And then you compare that point to another point and see what's happened. Okay, so normally, again, when you go over 1, you should go up 1. If it showed you an x value 2 units over, you think, well, normally in a cubic function, when you go over 2, you go up 8, right? Because 2 cubed is 8. So that's the type of thinking you need to use. Okay, example 5 here. Determine, I think this is our last example. Yep. Determine the x-intercepts and round to the nearest hundredth. Okay, so this is exactly like example 2. So really, this is just another practice for you. So please try this on your own and then watch the video to make sure you got it right. Are you pausing? Pause. Do it. Okay, so minus 2 bracket x minus 3 to the power of 4 plus 5 equals 0. So you get x plus minus 3 to the power of 4 equals 2.5, right? Because you had minus 5 divided by minus 2. So now I just do x minus 3 equals plus or minus the quarter root of 2.5. Okay, so from there you get x minus 3 equals quarter root 2.5, and x minus 3 equals the negative quarter root of 2.5. So I actually don't, I have to actually do this in my calculator, horror of horrors. So I just go 2.5 to the power 1/4, which does the same thing as the 4th root. Okay, and then I'm adding 3 to that. So for here, I get x equals approximately, that's what this dot means, 4.257. And here, I go negative bracket 2.5. Negative. Gotta try it again. This is not a good calculator. Okay, to the power bracket 1/4. Okay, and then I add 3 to that, and I get approximately 1.743 when I round. Okay, so that's the video about transformations. If you check your success criteria, make sure you can do all these things. Create the initial table of values for cubic and quartic. Understand each parameter, that should be a review. Use proper vocabulary, you guys are mostly good at that. Factor out k, determine the roots of a function. Create a transform table of values and sketch the corresponding graph. Determine the equation. If you're given a description of the transformations, and also if you're given a graph that's already been transformed, and if you're able to describe those. So transformations, they never go away, so you gotta learn to love them. Thanks for watching. Hope you learned lots.